Good morning to one and all. My name is Angela Ursula Portia, working as an assistant professor of physics in Erode Arts and Science College. Now I am going to discuss with you the topic 8086 Microprocessor Simple Programs. Now we discuss 8-bit addition program. For this, the data 1 is transferred to the AL register and the data 2 is transferred to the BL register. Next, the content will be added. The BL register content is added to the AL register content. The result will be stored in AL register, so that content will be transferred to the destination address 1200. Then stop the program. That's why we have to add the two 8-bit numbers using 8086 microprocessor. The next program is 8-bit subtraction. For this, the data 1 is moved to the AL register, data 2 is moved to the BL register. Next, the content of BL register is subtracted from the AL register. The result will be stored in the AL register and that result is transferred to the memory location 1200. The next program is multiplication. For this, the source index is initiated in the address 1500 and the destination index is addressed as 2000. So, first the source index content is transferred to the AL register. In the source register, we take multiplicand and then we have to increment the source register content. So, we can get the multiplier content. Next, the source index content is transferred to the BL register. So the multiplication, for the multiplication, the multiplicand is transferred to the BL register. Now the mul operation perform the multiplication. So here we are giving mul BL. Next, the result will be stored in the accumulator content and that accumulator content gives the product of the multiplication. Then it is transferred to the destination index. Already we declare the destination index as 2000. So we can get the output in the address 2000. Next, stop the programs. That's why we do the multiplication program using 8086. Program is division. Like multiplication, we have to perform the division. For this, we have to initialize the source index as 1500 and the destination index as 2000. For division, first we take dividend. Next, the source index is incremented and take divisor. Now the divisor is transferred to the BL register. So the instruction div BL is used to divide the dividend and divisor. The result will be stored in the accumulator and that accumulator result content is transferred to the destination index. That's why we do the division program using 8086. Program is 16-bit addition. For this, the source index is initialized as 1500. So here we are taking the first data. So next the first data is transferred to the BX register. So we have to increment the source index and get the second data. So the content is now in the AX register. So the instruction add BX, AX is used to add the content of AX register to the content of BX register and here the result will be stored in the BX register. So here we have to initialize the destination index as 1520. So the result BX is 16-bit result will be transferred to the destination register. That's why we have to perform the 16-bit addition using 8086 program. Next program is 16-bit subtraction. Like addition, we have to initialize the source index as 1500. The first data is taken into the AX register. That content is transferred to the BX register. So next content is taken into the AX register. Now the instruction sub BX comma AX is used to subtract the AX content from the BX content. The result will be stored in the BX content. So we have to transfer to the destination index. For the destination, we have to initialize as 1520. So the content will be, the subtracted content will be transferred to the address 1520. That's why we have to perform the 16-bit subtraction using 8086 microprocessor. Thank you for listening. Thank you.